Hey there! Turn on your speakers. Do you have finals week coming up? Projects due? Homeworks are piling up? Are you freaking out that you're getting boxed in with deadlines? Here's an idea. Get help. Think Geek Exams. Find us on Facebook, Twitter, or YouTube.
So this is the third problem in statics of the sixth homework, and here we have an object with in a 2D situation with 3 points A, B, and C on it, and there are three forces acting on these 3 points, F1, F2, and F3. We have the positions, and also we have the vectors, their magnitudes and their directions, given in different formats. So let's start by putting in the points. A is at, I'm going to do it in horizontal vector instead of, so 2, -1, 0. The reason we do the three-dimensional because we're dealing with moments. Moments are in 3D, so it's easier. So the next one is 1, 2, and 0. That's B. And the last one is C, and its position is -1, -1, 0. And we have ABC. Now we need F1. F1 is given straightforward in a Cartesian coordinate system in kilonewtons. And the answers are needed to be given in kilonewton meters, so I'm going to keep the calculation in kilonewtons. I'm not going to convert it into newtons by multiplying by 1,000. So this one is -2.4 kilonewtons in the I direction and -3.2 in the J direction and 0 in the K direction. F2 is slightly trickier. F2 is given in its magnitude is given, so I'm going to do a vector multiply to a scalar multiply of the vector, and the x-axis is cosine of of 30 degrees, and I need to convert that degree into pi into radians. So that's the x direction. The y direction is the sine, and the z direction is 0. So this would give me F2 in kilonewtons. And finally, F3 is I'm gonna do it. It's pretty similar. The magnitude, do a scalar multiply of the vector, and the x-axis is -12 over 13. We have a triangle here, a right triangle, 12 by 5. It's -12 on the x-axis and -5 on the y-axis. The hypotenuse is 13, so that gives us our unit vector, and it's 0 in the y direction. And that is those are our force vectors. Now to calculate our tau vectors. Tau. So first we're going to calculate tau, the moment for the F1 around O. So that's going to be T10, and the way we do that is cross between A and F1, and that should give us, yeah. So this is just the first step. We need to get F2, so this is going to be B, and this is going to be 2, and then this is going to be F3, this is going to be C, and this is going to be 3. And those are our 3 moments around the point O. So we need to add them up. T10 plus T20 plus T30. And that would give us minus 18. So I'm going to write that the magnitude as 18.5 to simplify. And since this is negative, it's going to be clockwise direction. As the next one is going to be around the point A, so we don't need to worry about F1 for point A because it goes through A. So we need to worry about F2 and F3. So let's start with F2. F2 is T to A, and this is going to be cross between. So we need the distance between B minus A, and we need the force F2. And that should give us a clockwise spin, so it's going to be negative. That is correct. So next one is T3 around A, and that's going to be C minus A and F3, and that should be a positive. Okay. Okay. Now TA equals to T2A plus T3A, and that is 11.35 in the clockwise direction. All right. Now we want B, and we want 1 and 3 for B. So B1 is going to be A minus B, and this is going to be F1, and 3B is going to be C minus B and F3, and TB equals to T1B and T3B. That should give us the correct answer for tau B, 20.8 in the clockwise direction. All right, I wonder why all of these are in the clockwise direction. Next is T1C, A minus C, and T2C, and this is B minus C and F2, and TC equals to T1C plus T2C. That is 18.55 in the clockwise direction, and that all the answers are correct.
Think Geek Exams. Our agents have Masters of Engineering degrees from MIT, Stanford, Georgia Tech, Caltech. We give you solutions to mathematics, physics, computing, and engineering. Find us on Facebook, Twitter, or YouTube.